Okay, this is the video for section 10.2. We're going to start off with having it face this way. We're going to fold towards those dotted lines. And we're looking at three major things. There are arcs. The arc is the outside of the circle, just that part right there. And once it's measured with the central angle, and what is a central angle? Is the angle that's created by the center of the circle. If it is less than 180 degrees, it's called minor. So for example, if I know that this angle right here is 135 degrees, so that's the angle ABC, then the arc is also 135 degrees. So they would be the same. A semicircle is when it does equal 180 degrees, and it's always denoted by three letters. So this looks like it's a little like pointy thing, but it's actually an arc that we make. For a semicircle and anything bigger, then we make it with three letters. That's why it says GHF. That is this whole side of the circle. So half of the circle. And it will always equal 180 degrees because the line that makes it is always a diameter or a straight angle, which is also 180 degrees. So it's either going to tell us that it's straight or it's going to tell us that it's a diameter. You can go ahead and go to her class. Minor arc. On the major arc, it's more than 180 degrees. So for example, if this one was 135, how do we get the minor arc? So remember, the notation is really a little arc, just that my font looks a little different here. We go in the order of the letters, so B, C, D. And that would be that arc measure right here. How we get that value is 360 degrees, because that's the degree of a whole circle, minus 135. So 360 minus 135, 225 degrees. All right, let's take a look on the inside. This is how your homework is. It's more like this. Let's name just a few of the arcs so you just get the idea of what I'm talking about. One of the minor arcs would be, for example, the arc EB. It could also look like this and be the arc BC, as long as it's less than 180. I'm not going to name them all, I think you understand, but they also can be a combination of two arcs, for example, like this. And that's the arc DB. You can name them in the reverse, so this could be BD as well. We'll just go in the order of the letters given. It tells us that EC is a diameter, so that means that this cuts the circle in half. Let's go ahead and do the problems that are on the side. It says that BAE is the angle, and that's this 140. I believe I made a mistake on this note, so it's supposed to be the angle measure of CAD because we don't define an arc by the center. So this was supposed to be the angle, the measurement of the angle, CAD. CAD is 100 right here. So I'm going to say that again. We never define an angle by the center. It's always by the points on the actual circle. So to find the measurement of the arc BE, it is 40. because it's the same as the central angle. BC is this one right over here. Since we know that this half of the circle is equal to 180, all we do is 180 minus 40, and that gives you 140, that it's that arc measure. So 180 minus 40 gives you that 140. The angle BAC is also 140, because if you know that the arc is 140, the central angle is 140. DE. DE is this one right here. Remember, this was half of the circle, so we would say 180 minus 100 equals 80, and that would be this arc measure, DE. Once we know the arc, we also know that central angle, the one that goes through the center, DAE, is also 80. DB, we can add these two together. The arcs are 80 and 40, so 80 plus 40 gives you 120. Like I keep mentioning, the arc is the same thing as the angle on the inside, which you can tell is also 80 plus 40. So the angle DAB is also 120. DC, and that's why I knew I made a mistake on here and how I told you about the angle, is because this is the arc right here, which would be the same as its central angle, 100. So the next section looks very similar. We're just going to take this information and plug it in. EAF, that's both of these together, is 110. And BF, just this one right here, is 60 degrees. So I want BE, I take 110 and subtract 60. That gives you 50 degrees. So that's 50 for the arc. BC is this right here. So what I can do is take 180 minus 50, and it gives me the arc BC, which is 130. Now I need the angle BAC, which is the same as its arc BC, 130. DE is this angle right here. Since it tells us that DF is also a diameter, that means that I can take this, which is 110, and subtract it from 180. So 180 minus 110. So let me point this out. If I take this away, which is 110, gives you 70. The angle DAE then is also 70. So the central angle and the arc are equal to each other. DB, it has to be the lower, it has to be this way like this, because if we go this way, this is a major arc. And it has to be denoted by 3 letters. So we're just talking about these two. DE was 70. Remember, this was 70 and this is 70. So that means to get DB, we just add 70 and 50 together, which gives you 120. Now the angle DAB, we still add those two angles together. They're going to be the same as the arc, 120. DC. DC is this measurement right here. Don't forget that this is 180. So 180 minus 70 is 110. Our last section was about major arcs. So major arcs are when it's equal to more than 180. So for example, arc BCD or I could even say the arc ED and go all the way here to B. It needs 3 letters to be named a major arc or a semicircle. So here I forgot to mention the semicircles. They still have that arc measure, and you just write 3 letters. D, C, F, half of the circle. Or the arc, let's write E, F, C. There's more examples. I just want to make sure that you understand what I mean. That it has to have 3 letters if it's going to be a semicircle or a major arc. Let's go ahead and find the values. I'm looking for angle EAB is 45. And the arc, so that would be a major arc, is ECD. Woo, let me erase this one so it's not confusing. It's 280. So it wants BE. The angle is 45. That means the arc is also 45. They're equal to each other. BC. It tells us that EC is a diameter, so that means that this equals 180. 180 minus 45 gives you 135. Then the angle BAC will also be 135, because if the arc is 135, the central angle is 135. DE. How do we get DE? The easier way is 360 minus 280. Because all we're missing from that circle is this part right here. We already knew that this was 280. And that gives you 80. Now I need the angle DAE. Since the arc was 80, the central angle is 80. DB. We're going to add these 2 angles together or these 2 arcs together, still 80 plus 45, which give you 125. The arc ADAB, the angle, we're going to add those 2 or it equals the arc, 125. BC has to be 100 because 180 minus 80 that we already have for this section is equal to 100. On the back, if you don't mind, I forgot to write an example of one of the problems that's on your homework assignment. It says find the length. Of the arc. Remember, length in a circle is called circumference. Length in a circle is called circumference, so what we need is the circumference of the whole circle. Let me give you the example when r is equal to 5. Remember that circumference is 2 pi r. So that means that for this example, we have 2 pi times 5. That becomes 10 pi. Why do we need that? We need it because the way we get the length of an arc, that's only a little section of the circle. We have to compare it to the whole circle. That's 360 degrees for the whole circle and 10 pi for the circumference. So the whole circle in degrees, the whole circle circumference. That's going to be equal to the little part, let's call it L. The little part of the circumference that we're looking for, or the length, compared to the angle of the arc. I'm going to say that it's 100. And I'm going to tell you right here that this is the angle of the arc. So this is just an example. What you're going to have to do is cross multiply. And I set this up wrong, sorry. This goes up here, sorry, because degrees goes with degrees. That means that the length I'm looking for is right here, because that's the whole length and the little part of the length that I'm looking for. We still got to cross multiply. 360 length is equal to, and then 100 times 10 is 1,000 pi. Then we divide by 360. The length of the arc is then 1,000 pi. So how do you get pi? There's the second, and then here's the little hat symbol for the power. It's above the division. And then you hit divided by 360, and you get it's approximately 8.73.